All right, here we go into 7.5, part 2. We have had worked all the way up till example 4, extra example 4 there. And I asked you to go ahead and finish that, okay? And then do your turn problems 3, 4, and 5. Now we're going to look at example 5, and that's going to be looking at the idea of an inverse of these rational expressions, rational functions. Okay, so we want to consider this function, f of x equals 7 all over x plus 5. Okay, so we're going to look at this guy right here. Okay, so we're going to look at this guy right here. So what I'm going to do is determine whether the inverse of f is a function, then find the inverse. So what I'm going to do is I'm going to look at the graph of it. So I'm going to use Desmos. Okay, so here I have graph the function. Okay, and if we notice this function, okay, this function, okay, this function as we trace along it from here, okay, as we trace, okay, it's going to decrease here, and then it's going to come up here and decrease again. So this function is always decreasing. It has this asymptote, okay, right here at -5. Because if you look at the original function, I can't put a -5 in that. So if x equals -5, we would have that asymptote right there. Let's go ahead and change it. Oh, turn it on. Let's change the color on that. Let's make it purple. Okay, so there's our asymptote. Okay, x equals -5. But we need to decide, does the inverse, is the inverse a function? And then find the inverse. So to determine whether it has a function, I'm going to actually look at a vertical line. And if I sweep a vertical line through this function, okay, if we look at that vertical line, as I sweep a vertical line through this function, this vertical line will never cross this function at more than 1 point. Okay, so it passes what we call the vertical line test. So that means it is a function. Okay, but then we need to look at a horizontal line also. If I look at this horizontal line and I pass that horizontal line up and down, this function, it'll never, if I keep going up or down, it's never going to cross this function at more than 1 point. Here it crosses right there. Okay, let's go to that guy. So it's never going to cross it at more than 1 point. Wait, why did I lose that one? I wanted to talk about that guy. Okay. Oh, no. Hey, it never crosses at more than 1 point right here, that point of intersection. Okay. So it also passes the horizontal line test, which tells me that this function is what we call 1-to-1. Okay, the function is 1-to-1, so therefore its inverse is also a function. So since it passes the both horizontal and vertical line test, okay, let's wait a second. Okay, since it passes both the horizontal and vertical line test, so it passes both horizontal and vertical line tests, it is 1-to-1. What we call 1-to-1, if you remember we had that discussion on 1-to-1 a while ago. It is 1-to-1, so therefore its inverse is a function. So now it wants us to find the inverse. So to find the inverse, what I want to do is first write it as y equals instead of f of x equals. And now to find the inverse switches that x and y. So I'm going to switch this x and that y. So now I'll have x equals 7 over y plus 5. Okay. Now I could write this x as a fraction. So now I have a fraction equals a fraction, so now I can cross multiply. So I'd have x times y plus 5 equals 7. So I'd have xy plus 5x equals 7. So now I'm going to subtract the 5x from both sides. Again, we're trying to solve for y. And then divide both sides by the x. So my inverse would be f inverse of x would be equal to 7 minus 5x all over x. Oh, scroll up a little. all over x. So there is my inverse function. Okay. So there's my inverse, and again, that idea on what an inverse does. If we come back here to Desmos and we graph that inverse, 7 minus 5x over x. So if we graph that, let's call that a g of x. Okay, and it was 7. Let's put that in parentheses. The entire numerator was 7 minus 5x. I don't know what happened to my 7. And divide that by x. There's my inverse. Let's get rid of these guys, get them out of the way. So there's my inverse. So again, we have that reflection over the line y equals x. Remember that line of reflection? So we have the one is reflected of the other right there along that green line, how inverses work. Okay. All right. Okay, we have one more example to do. Example. Is it 6? Let's wait, bring it back. Okay, so we have this one more example to do. Here, example 6. I'm going to make some room here. Okay, so here for example 6, it says 2. In section 7.2, extra example 5, I don't think we did that problem, but it said you wrote the function c equals 25n plus 1500 over n, which represents the average cost of plotting n blueprints using a plotter. Find how many blueprints must be plotted for the average cost to be $75 by each method. So the first way, it says to do it by solving an equation. So if the average cost, it says the average cost is $75, so that's my C. I want to find N. So I'm just going to start by replacing my C with 75 and solving that equation. So we'd have 25N plus 1500 all over n. So I'm going to write that over 1. So I'm going to cross multiply. I need a little more room. So we'd have what? 75 n equals 25n plus 1500. Let's subtract 25n from both sides. So we'd have 50n equals 1500. And 1500 divided by 50 is 30. So n is 30. So the number of blueprints would be 30 blueprints, okay? And so that was by just solving that equation. Okay, let's go ahead and let's do this one another way. Let's see, let's use orange. By using the inverse of the function. So I'm going to find the inverse of this function up here. So I'm going to find the inverse of that guy right there. Okay, so to find that inverse, what I need to do is right now it's solved for C. We've got C equals. I want to now solve it for n. So I'm going to go ahead and I'm going to work with that equation. So we have C, here, right here, C equals, we've got 25n plus 1500 divided by n. I'm going to write that as C over 1. And again, now I'm going to cross multiply, but I'm not going to put my 75 in yet. So we cross multiply, we'll have Cn equals 25n plus 1500. I'm going to subtract the 25n from both sides. On this side, I can factor out an n. And then now I can divide by a C minus 25. So then n equals 1500 divided by C minus 25. So there's my inverse right there. So there's my inverse. Solve for n. But now to figure out how many blueprints I could do if I had a cost of $75, I can just plug it right in there for C. So I'd have 1500 divided by 75 minus 25. So I'd have 1500 divided by 50 again is 30. So we still get that exact same number, but now with this equation, let's go ahead and use a highlighter. With this equation right here, okay, I can very easily change the average cost. I can plug in anything I want for this C right here. Say I wanted the average cost to be $50, or if I wanted to be $100, or if I wanted to be $200. I can plug in whatever I want from there and very easily get from there to here without having to go through this entire process every single time. I go through that process once to find the inverse, and then it's very easily to just plug into that inverse. So that's our inverse right there again. I can just very easily plug into that inverse to get those pieces. Okay. So now I want you to have a little bit of practice of your own. So here's some your turn problems. Number 6 and number 7. I want you to do those 2 your turn problems and then check them with me and go over them either with me or with a peer to make sure that you have the right process before you get started on the practice. Good luck.